All right, so let me share. I'm going to share screen one, and minimize this and bring this over. All right, so I'm going to open up my Apache Guacamole. Clean this up a little bit. Log in. Use my Authy app. The same things you guys have to do, I have to do too. And Authy. And log in. All right. So when you connect, so if you go to the lab file, so let's open the lab file together. So here's the lab. So we change things up. If you go to there, I want you to connect. Now, when you click on the Spring 2021 CNET58, you're only going to see your server. You only have access to your server, right? So if you come here, you're going to see, I see all of them, but you'll only see your server. So mine's L1. So when I log into my server, this is what we're going to see. What I want us all to do, so go ahead and log into your server. Let me know in the chat if you have any problems getting on there. It should automatically do that for you. Pull up the chat. All right, so go ahead and log on to Authy or to the Guacamole and get over to your server. And the first thing I want you to do is let's change our background. So let's go into our personalize, and then go click on background. And oh, it's turned off by. That's it. Accent. Okay. I thought there was a way to change the background color. Anybody know how to do that in here? So let me see something in Guacamole. There might be a place I can change that on. Okay, enable wallpaper. Let's see what that does. So oops. All right, so now, okay, I'll have to go through your settings, but I'll do that while you're working on the lab. But what we need to do is change this background, and let's make our background red. Okay. So let me go through your settings here, and I'll change that. Enable background. So you'll just have to disconnect and reconnect. All right. Let me get these updated real quick. Because I do want everybody to change their background to a solid color, red preferred. So if you can't change yours, just log off and disconnect and reconnect. And if I've changed it, you'll have an option to do it. Just a couple more. Two more. All right, so if you go into your server, you should be able to change your background now. So if you just right click, personalize, for the background, change it from picture to solid color, and then pick this red. Let's make sure we have a nice red background. Okay. So whenever you log into your server, that's what you should see is your machine with a nice red background. And the reason I want it red is if you're ever doing anything and you realize you're on this red computer here, you're on the wrong one. Okay. The other thing I want you to do is right click start and on run, type sysprep and hit enter. You should either get where it says cannot find, or you'll see a folder, but there is no sysprep.exe in there. Make sure there is no sysprep in there. So I'm going to disconnect here and go to another machine. So like this machine, if I right click run, when I open this folder, see how I have a sysprep here? Yours should be gone. You should not have a sysprep. If you have a sysprep like this, let me know. Tell me in the chat that, hey, I'm seeing a sysprep. This exe, you might see these two folders, but not the sysprep application itself, the tool. That should be gone. Okay, good. Okay, the other things we want to do. So once you confirm that is gone, the next thing I want you to do is right click on the start, go to PowerShell, and I want you to type host name and hit enter. You should see this name should be the same as the name in the tab that you're connecting to Guacamole. Yours should say server dash L1 through L13 or R1 through R14. Okay. If it says win dash something like this one, that is not correct. Okay. So if it does not say server dash R something or L something, send me a message in chat and I'll help you get that changed, because we want to make sure these machines are set up properly. All right, so far so good. All right, so I'm gonna pause right here and make sure everybody has all of that taken care of. It should be done because I set these up yesterday and I configured them all yesterday afternoon. So they should be the way they are. But when you're doing 27 of these as fast as you can, sometimes you might miss something. Okay, good. All right. So I'm gonna get out of this one. The other thing, okay, server L2. All right, so JP, can you share your screen with me? All right, so exit out of that. Just type exit. Okay, hit enter. Click on start. And then at the top, hit server manager. And then click local server. And then click on that win ugly name. Change. And then type, oh, it is server L2. Hit cancel. Hit OK. And we just have to restart your server. So right click. Okay, so you don't have restart. Go into, let's try this. Go into PowerShell admin and type restart. Hit enter. Reboot, try reboot. There's a do shutdown. Okay, so yeah, scroll up. Do shutdown /R. See what that does. Yeah, scroll all the way down. Yeah. Okay, yeah. Close. All right, that will log you off. And then when your machine restarts, it should have the correct name. So can you log off? Okay, good. All right, everybody else is probably in good shape, hopefully. All right, so here's my screen. I'm going to disconnect. Back to my server, L1. All right, so the next thing we want to do is go into start and run and go into gpedit.msc. Okay, that should be, if you hit the down arrow, you should see that in there. So go into the group policy editor and then make this full screen. And what we need to do, in order for our file share to work, we have to configure some stuff here. So let's go into administrative tools and then double click network and then double click LAN man workstation. And then double click this enable secure guest logons. And then click on enabled and then click on apply and OK. Okay. If that is not on, you will not be able to get to the file share. So with this on, now if you come into the file share, you have access to it. If you get to where you type in this number and you get an error, that means you need to come into this GP edit, computer configuration, administrative templates, network, LAN man workstation, enable insecure guest logons, and enable it. By default, it's not configured. Click on enable, then hit OK and apply. All right. So everybody, you should make sure you have that going. All right. So far, so good. Okay. All right. So Luis, right click on start, go into run, type in gpedit.msc, hit OK. Make that full screen so you can actually see some of this stuff. Click on administrative temples under computer configuration. Asking for credentials. Okay, Luis, where are you at? Louis, I'll come back to you. Luis, okay, administrative temple, double click network, double click LAN man workstation, and then this enable insecure guest logons, make sure that's enabled. So you can double click it, click on enabled, and then click on apply and OK. All right, Louis, can you share your screen? Let me stop my share. You can share your screen. Oh, for the credentials, for the share, it's CNET58, CNET58. That's in the lab. I didn't say it. I'm sorry. Yeah, CNET58. There you go. Then go to CNET58. And then sort by size or size, yeah. And grab those first three and copy those to your desktop. Or you create an ISOs folder in your C drive. Yeah, wherever you put them is fine with me. Okay, and then just drag those three. Yeah, okay, there you go. Okay, so that was easy. That was a easy fix. All right, so while those are copying, hopefully you guys can get all those. Yeah, computer config, add landman workstation. Yeah, Ian, JP's got it there for you. Computer config admin. These instructions are in the lab too. I wrote them out. I didn't give a picture. No, what you're going to do from here, let me share my screen for you, Louis. So from here, if we go to, and if you click this and you get prompted for a username and password, it's CNET58, CNET58. Come in here and sort it by size, and then just copy these first three. And so hit copy, and then come to your machine, create an ISOs folder, and then paste them to your ISOs file. Does that make sense, Luis? If not, share your screen, I'll help you. Okay, go 10.28, 72.50, enter, share, CNET58, CNET58. Click more choice. It's no uppercase. You have an uppercase C there. Okay. Scroll down a little bit. Use a different. Put lowercase CNET58. Lowercase CNET58. You gotta go, huh? Okay. Click the CNET58 folder. Over on the size in the upper right-hand corner. Yeah, click that. Yeah, okay, now select all three of those. Just control click, hit the control key, click on all of them. Get server, right click on it, copy. Okay, go click on this PC, double click your C drive, right click in a white space in the bottom, new folder, ISOs, double click, right click, paste. And there you go. So now those three files will be in that folder because the instructions will have it all set up for that. All right, go ahead and stop sharing and we'll let that do its thing for a little bit. There it is. All right.
Hi, class. Bye, class.
That's my wife. All right. So let me go back to the lab and share that. All right, so here we are now at this copied ISOs over from your Hyper-V host. Here's the problem, here's the fix. Okay, so now I'm going to show this video here. All right, so while all this is copying, can you see this video, or did you lose it? You can see that I'm on YouTube? Okay, good. All right, so I'm gonna skip this ad. So while this is copying over, let's watch this video real quick.
In the last lesson, I demonstrated how to install the Hyper-V role. Now that the role is installed, we can start to create virtual machines on our Hyper-V host. In this lesson, I will provide a brief recap on what virtual machines are and how they work. Next, I will look at virtual machines under the hood and will discuss the different components that make up a virtual machine. And finally, I will demonstrate how to create a virtual machine on my Windows Server 2012 R2 Hyper-V server. As I described in the introductory lesson to this course, virtual machines are essentially software computers that run an operating system. You can think of virtual machines quite literally as regular computers, except they run entirely in software. Virtual machines allow businesses to cut down on hardware costs by having two or more completely separate operating systems running on the same physical computer at the same time. You should not think of virtual machines as any less of a computer just because they are software-based. Virtual machines are every bit of a computer as their physical counterparts, and are just as capable of performing the same tasks. If you have ever purchased a computer in a shop, before you buy it, you will often have to decide how powerful you'd like it to be. That is, you will have to decide how much CPU, RAM, and hard disk space you require. The same is true for virtual machines. Virtual machines, just like regular computers, require their own CPU, RAM, and disk space. When you create a virtual machine, you have to decide how powerful you'd like to make it. For instance, if the virtual machine is running some kind of memory-intense application, you may wish to allocate it more memory. Alternatively, if the virtual machine will be used as some kind of a file server, you may wish to allocate it more hard disk space. Since virtual machines are entirely software-based, the resources you allocate to the virtual machines will come directly from the Hyper-V host. This is why the Hyper-V role is typically installed onto very powerful computers with a lot of resources, so that both the host and guest systems are able to run smoothly. Now that we have recapped what virtual machines are, I will next take a look at virtual machines under the hood, including the files and components that make up a virtual machine. When you create a virtual machine in Hyper-V, you are essentially creating the software equivalent of a bare metal computer. In other words, you are building a software computer that does not yet have an operating system. After the virtual machine has been created, you are then able to install an operating system onto it. The virtual machine itself is essentially an XML file. That is, for every virtual machine you create, an XML file is created. The XML file stores all of the virtual machine settings and configuration data. Virtual machines are also assigned a globally unique identifier, or GUID, on creation. A GUID is a randomly generated alphanumeric code that is used to uniquely identify the virtual machine. A virtual machine's XML file is named after its GUID. By default, virtual machine XML files are stored in the C Program Data Microsoft Windows Hyper-V directory. Later on in this lesson, I will create a virtual machine and will show you the XML file associated with that virtual machine. Now that we have discussed the XML file, I will now look at the components that make up a virtual machine. As I mentioned earlier, when a virtual machine is created, resources have to be allocated to it. The first resource to allocate is CPU, or processor power. On a physical computer, the CPU, or processor if you prefer, is what retrieves and executes data stored on the computer's hard disk. Theoretically, the faster the processor, the quicker this can happen. The same principle applies to virtual machines. Virtual machines, just like physical computers, have to have processors which can pull and execute data from their virtual hard disks. The amount of processor power that can be allocated to a virtual machine is dependent on the number of processor cores available in the Hyper-V host. For example, if the Hyper-V host has 2 physical CPUs, and if both of those CPUs are quad-core processors, this comes to a total of 8 processor cores, which can be assigned to virtual machines. In Hyper-V terminology, a CPU core is also called a virtual processor. According to Microsoft's documentation on Hyper-V, you can assign each virtual machine up to a maximum of 64 virtual processors. By default, Windows will allocate just 1 virtual processor to every virtual machine created, so make sure that you increase this if you think it is necessary. The next resource to allocate is RAM memory. On a physical computer, when an application or data file is opened, it is retrieved from the hard disk and is loaded into RAM. Once loaded into RAM, you are then able to use it. Theoretically, the more RAM you have installed, the more programs and data files you can have open and running at the same time. Since virtual machines are computers, they too require RAM to run the applications you install onto them. With Windows Server 2012 and Windows Server 2012 R2, there are 2 ways that RAM can be allocated to virtual machines. The first method is called static memory. With static memory, the amount of RAM you choose to allocate to the virtual machine is allocated all at once. That is, if you make the decision to allocate 4 GB of RAM using static memory, 4 GB of RAM is essentially taken from the Hyper-V host and is given exclusively to the virtual machine. In other words, that 4 GB of RAM now belongs to the virtual machine, and only that virtual machine is able to use it. Although effective, there is one small problem with this approach. If you later wanted to change the amount of RAM assigned to a virtual machine, you would first have to shut the virtual machine down. Only whilst the virtual machine is powered down can you adjust its memory. When Hyper-V first made its debut in Windows Server 2008, static memory was the only way to assign RAM to virtual machines. Network administrators were left to debate how best to allocate their RAM resources amongst their virtual machines. To address this issue, Microsoft introduced an alternative method of assigning RAM, called dynamic memory. Dynamic memory was first introduced in Windows Server 2008 R2 with the release of Service Pack 1 and was improved further in Windows Server 2012. Dynamic memory is designed to allocate RAM amongst virtual machines more effectively. Dynamic memory does this by treating RAM as a shared resource. Rather than simply carving up the RAM in the Hyper-V host among the virtual machines, dynamic memory allocates only the amount of RAM required by the virtual machine at that specific point in time. That is, if a virtual machine suddenly experiences high workloads, more RAM will be allocated. And when the workload quietens down, the amount of RAM allocated will be reduced. Doing this ensures that there is plenty of spare RAM available in the Hyper-V host, as opposed to it being constantly allocated to virtual machines. In their time of need, virtual machines can simply request more RAM from the host and return it when the need passes. Later on in this training course, I will demonstrate how dynamic memory works in a lot more detail. According to Microsoft, you can allocate each virtual machine up to a maximum of 1 terabyte of RAM. The next resource to discuss is hard disk space. On a physical computer, a hard disk is simply a device which stores data, including the operating system, applications, and data files. Virtual machines are no different and require their own storage devices. Virtual machines require at least one virtual hard disk to store their data. A virtual hard disk is nothing more than a file stored on the Hyper-V host that acts like a hard disk. Once created, the virtual hard disk is attached to the virtual machine. In Windows Server 2008 and Windows Server 2008 R2, all virtual hard disks created in Hyper-V ended with the .vhd file extension. The .vhd format of virtual hard disk can be as large as 2 terabytes in size. With Windows Server 2012 and Windows Server 2012 R2, however, you are able to create 2 types of virtual hard disks. Both systems are backward compatible and allow you to create the original .vhd format of virtual hard disk. However, they also allow you to create a newer .vhdx format of virtual hard disk. Virtual hard disks that use the newer .vhdx format can be as large as 64 terabytes. Also, in the event of power outages, .vhdx virtual hard disks are less likely to become damaged or corrupted than the older .vhd format. The only drawback to using .vhdx files is that they are not backward compatible with earlier versions of Hyper-V. .vhdx virtual hard disks can only be used with Windows 8, Windows 8.1, Windows Server 2012, and Windows Server 2012 R2 Hyper-V servers. The final resource I'd like to mention is network connectivity. In order for a physical computer to participate in a network, it must have at least one network interface card installed. The network interface card is programmed with an IP address, and the computer is then able to communicate with the other computers on that network. Fortunately, virtual machines are also capable of networking. With Hyper-V, you are able to join all of your virtual machines to your network, just as you would a new physical computer. However, before a virtual machine can be added to the network, you first have to create at least one virtual switch. Virtual switches provide virtual machines with network connectivity. You can think of virtual switches as network adapters for virtual machines. Virtual switches.
You're
are
right,
created
Ian,
from
he
the
does.
physical network adapter
That is a funny
installed
show.
in the Hyper-V host. When you are ready to join a virtual machine to the network, you are first required to select one of the physical network adapters from the Hyper-V host and turn it into a virtual switch. Once the virtual switch has been created, you can attach it to the virtual machine. The virtual machine will see the virtual switch as a locally installed network adapter, which can be assigned an IP address. This puts the virtual machine onto the network. It is worth noting at this point that you are able to attach the same virtual switch to multiple virtual machines if you wanted to. However, this may cause some bandwidth issues, since multiple virtual machines will be communicating with the rest of the network via the same physical network adapter. For this reason, it is not uncommon for network administrators to install many network interface cards into their Hyper-V host, so that each virtual machine can be assigned its own dedicated virtual switch. According to Microsoft, you can add up to a maximum of 12 virtual network adapters to a virtual machine. This covers the core components that make up a virtual machine. Of course, there are other components that can be added, but these are the main ones. Don't worry, I will be covering these components and other components in a lot more detail later on in the course. Now that all of the components are covered, I will now change over to my Windows Server 2012 R2 Hyper-V server so that I can demonstrate how to create a virtual machine. To create a virtual machine in Hyper-V, first, open Server Manager from the bottom left corner and select Tools from the top right corner. From the drop-down list, select Hyper-V Manager. This will open the Hyper-V Manager console. In the left pane, notice that my Hyper-V host, Hyper1, is listed. To create a virtual machine on this host, right-click the Hyper-V server, point to New, and select Virtual Machine. This will open the new virtual machine wizard. The first page you will see is the Before You Begin page. From here, just click the Next button. The next page is the Specify Name and Location page. The first option on this page allows you to choose a name for your virtual machine so that it can be identified in Hyper-V Manager. For now, I will name my virtual machine vServer1. The option below this allows you to choose where to store the virtual machine. By default, Windows will attempt to store the virtual machine on your C drive in the C Program Data Microsoft Windows Hyper-V directory. Of course, you are able to store the virtual machine in a different location if you wish by ticking the Store the virtual machine in a different location checkbox. Personally, I like to store my virtual machines on a completely separate hard disk to my operating system. So I will change the location to my D drive, which is on a completely different hard disk. When you are ready to continue, click the Next button. The next screen is the Specify Generation page. This page will only appear if you are running Windows Server 2012 R2. From here, you are asked to select a generation of virtual machine to create. Generation 1 virtual machines are essentially the same as the virtual machines created in all previous versions of Hyper-V. All virtual machines created on Windows Server 2012 or earlier will be Generation 1. Generation 2 virtual machines are brand new to Windows Server 2012 R2 and provide more advanced features and functionality not found in Generation 1 virtual machines. Since Generation 2 virtual machines are a new feature, you are only able to install the newest Microsoft operating systems onto them, including Windows Server 2012, Windows Server 2012 R2, 64-bit versions of Windows 8, and 64-bit versions of Windows 8.1. To keep things simple for now, I will stick to the more commonly used Generation 1 virtual machine. I will cover Generation 2 virtual machines later on in the course. After selecting which generation of virtual machine you'd like to create, click the Next button. The next screen is the Assign Memory page. From here, you are able to decide how much RAM memory you'd like to assign from the Hyper-V host to the virtual machine. By default, Windows will attempt to use static memory and will assign 512 megabytes of RAM. To continue using static memory, all you have to do is enter the amount of RAM in megabytes that you'd like to allocate to the virtual machine in the startup memory field. For instance, to allocate 4 gigabytes of RAM, enter 4096 megabytes. Alternatively, you can use dynamic memory assignment by ticking the Use Dynamic Memory for this virtual machine tick box. To keep things simple for now, and since dynamic memory will be covered later on in the course, I will stick to using 4 gigabytes of static memory and will then click the Next button. The next screen is the Configure Networking page. From this page, you are able to configure network connectivity for your virtual machine. If your virtual machine has network connectivity, it can communicate with the other computers on your network. To provide network connectivity for a virtual machine, you first need to create a virtual switch. A virtual switch is created from a physical network adapter in the Hyper-V host and is essentially a network adapter for a virtual machine. If you have a virtual switch configured, you can select it from the connection drop-down. Of course, if you would like your virtual machine to be a standalone computer without any network connectivity, you can simply leave this on the Not Connected setting. As you can see, at present, I do not have a virtual switch to select. This is because I have not created one yet. Don't worry, I will demonstrate how to create.
All right. Well, if you really want to, you can watch that video on your own. Okay. I'm going to go back to the lab. So basically what you're going to do, and on our machine, so if you open Hyper-V, and yours should have your name there. And if you right click new or action new, or over here, new virtual machine, what we're going to do is create a Windows 10 virtual machine, and we're going to call it Win 10 parent. So this will be Win 10-parent, which is going to be a Gen 1. We're going to give it 2 gigs of RAM, 25 gig hard drive. So 2048 connected, get the connected the down, and you should see this Intel connection. All of us should have that. Yours might be a number 2 or number 1 or number 3, just depends on your server. But connected to that, click next, change this hard drive size to 25 gigs. Okay, then click next. And then we're going to say install an operating system from a bootable ISO file. Click browse, and then I'm going to go to my ISOs folder and select Windows 10. Then I click next, and then I click finish. Okay, and then I'm going to do the same thing for CentOS and the same thing for Server 2019. And then once I have this going, I can click on this and I can click connect, and then I click start, and this will take me into the setup. Okay. So this will go through the setup process just like we've done before. And then by the end of today, I want you to have installed and set up Windows 10, Server 2019, and CentOS. Okay. And then there's some directions here, give the username of the password to CNET 2021. You might have to create a user here too, call it CNET58, like we did previously. And then this one, you're in there. And then once, skip this number 1 where it says rename the computer. You don't have to do that for the server because we're going to rename them. Just let it, whatever the name is for that, leave it like that. It's no problem there, but give it the password as CNET 2021 exclamation point. And then when you're done, just answer these 5 questions, which you can probably get out of today's lecture, as well as, yes, Robert, you can always go back into the settings and add it to the switch. And you can do that with it running. So in that case, you would just come into here where it's running. And if you go File Settings, Network Adapter, and then you can just click this down, click here where it says not connected and connect it. And then hit OK. All right. So that's no problem there. And then just answer these questions and then submit this to week 9. All right. So there's not a lot in today's lab, although it's going to take some time because we have to reinstall 3 operating systems. Okay. So I'll be on Zoom should you need me. And if you have any, yes, good. Michael, make sure you select the data center desktop edition. It's the bottom selection. If you ever install Windows or server in this class, always select the bottom selection, which is the data center desktop edition. Thank you for pointing that out, Michael. All right. So that should be it. You should have everything you need to get going today. But make sure and then submit this. You have really until Sunday night at 11:59 to finish this lab if you want to. I would recommend you do it, today while we have time. No, there's no more ESXi. Everything is on Hyper-V. So yeah, from now on, this is our only connection. We'll just log into our server again, should have a red background, and then we'll go from there. Okay, then you come into here and you create your 3 VMs. So at the end of today, you should have Win 10 parent, Win server dash parent, and CentOS 8 dash parent. All right. And they should all be installed with an operating system, because next week we're going to take these parents and produce some children and start doing some more servering with it. All right. I'm talking and I'm not sharing my screen, but that's okay. All right, it's in the lab. Luis, everything is in the lab, so you're good to go. But if you have questions, just shoot me a chat or find me online and I'll help you. I'm gonna stay on the Zoom until 3 o'clock or 2 o'clock. I have a meeting at 2 o'clock, so I'll jump off at that time. All right, guys, just let me know if you need anything, and then you're free to go do it on your own if you want. Oh, you're welcome, Louis. Yeah, and obviously you're gonna, if you don't remember how to install Server or CentOS or Windows 10, go back to lab 1 and lab 2, where we have the instructions, you know, where I tell you do this, this, and this. At this point, I'm just assuming you've done that before. You should be comfortable doing it. Really, it's next all the way through. So.